Hello, this is video number 31, and congratulations. You survived the lower level computer science part of this course. Now we're at the middle level. We're no longer wallowing around in bits and bytes. The physics analog was what, atoms and electrons and all that. Now we're at the bouncing ball, programming and stuff, where most people think computer science sits. Maybe it is the center, since it's the middle level. That's enough intro about that. We need to talk about the next thing, which is in fact the middle level, software. The lower level was all about hardware. The middle level is all about software. Software, you could think of that as the programs or apps. Same thing. I can't spell apps. Programs or apps that run, also known as execute or execute, on the hardware. So, all the stuff we've looked at so far, that's hardware-y stuff. That's at the low level, AND gates, OR gates, other kind of gates, processors, addition, all that stuff. The software is, I guess, the analog of, if the hardware stuff is your brain, then your thoughts and your feelings and all that sort of stuff, the ephemeral stuff that's in your memory as you're thinking about it, that's your software. And same thing here. The software, while it's running, it's in memory, and we know what that means now. The software is going to be loaded out of long-term storage into memory, and as little pieces of it are needed, they're loaded into the registers, and the CPU does its thing. See how much you know about this already? Except we don't have any software for our hardware to run yet. I need to talk about what a program is. I'm going to refer to them as programs, but think of programs and apps as being interchangeable. A program is a sequence of instructions for a computer to execute. A sequence. I'm going to underline sequence. Why? Because it's very different from a set. A set means the order doesn't make any difference. It's either in the set or it's not in the set. A sequence implies a lot more. A sequence implies that, well, you better do step one before you even think about step two, and so on down the line. An example from the real world, rather than the computer world, might be a recipe. If you follow the recipe in the wrong order, and I don't know any recipes. If you don't crack the eggs into a bowl and beat them before you put in the salt and pepper and everything, if you put the salt and pepper in first and then crack the eggs, oh my, you're going to have eggshells all over the place. It'll be a disaster. Yeah, that's not a good example. But just keep in mind, here's what you can run in your own software processing brain. Keep in mind that the order of the instructions makes a huge difference. Exactly the same instructions scrambled around are going to be doing something completely different. I've already used up too much space for the picture I want, so I'm going to hurry up and erase this. Just as with the hardware, if you recall, we did the input, output, and long-term storage and all that stuff. Here is a diagram that represents the life cycle of a program. Even its life is a sequence of events rather than a set. Life cycle of a program. It starts its life. I've got a dog hair right under my feet, so if I fall down in the middle of this video, feel free to laugh. It's my own darn fault. The starting of the life of a program, it starts in this box as the program's source code. S-O-U-R-C-E-C-O-D-E. After it's completed as source code, it has to turn into what's in the second box. Of course it does. What's called object code. That sounds a little mysterious. Well, if you thought that was mysterious, it has to turn into yet another form. It's just morphing around all over the place. It's got to turn into executable code. before the computer will even have anything to do with it. And to add even more mystery to this already mysterious picture, over here I'm going to put in a dotted box. Ooh, a ghostly dotted box. We're close enough to Halloween, I can do that. This is library code, L-I-B-R-A-R-Y, library code. And it's got an arrow also going into executable code. So far we've got the original version, the source code, and these arrows are one way. The source code has to be turned into object code. Object code becomes executable code somehow or another, being combined with library code. And finally, the box at the bottom, which I barely have room for because it's such a big picture. This is the program's core image. I put core in quotes. That's kind of a legacy term, but you'll still hear it called the core image, even though memory is not made up of cores anymore. Cores are little iron donuts that stored 1-bit value. If the magnetism was spinning one way, it was a 1, and spinning the other way, it was a 0. Dinosaur era computing. Now then, what does that have to do with anything? I'm going to put a dotted line right here to separate the things that are below the dotted line and above the dotted line. Above the dotted line over here, I'm going to say that all of this stuff, these versions all live in long-term storage. I can't spell LTS. They all live in long-term storage. This is the only one, core image. This is the only one in memory. Now the source code, that's going to be in memory when we're typing it in. Think of that as maybe a word processor document or something. But the computer doesn't have anything to do with it while it's still source code. If we want to run our program, it eventually has to be a core image in memory. That's what's pulled in out of long-term storage into memory. When we click on an icon, listen to all these terms I can just throw around knowing that everybody knows what they are. Now then, all of this actually, this whole picture, I'm going to have, Solomon, you're going to have to move. I'm standing in front of the picture. Move, Solomon. Get up. He won't move. Okay, I'll lean back. There. I hope you can see the picture now. I'm going to number these boxes because I'm just going to have to erase the whole board and start over and talk about each one separately. So for future reference in video 32, this is box 1, box 2, box 3 is the library code, box 4, the executable code, box 5. But wait, there's more. Don't turn off the video. I did all that in one color. Here's another color. How do we get source code? We don't know yet because we haven't seen video 32. We don't even know what it is. But it has something to do with what's called an editor. E-D-I-T-O-R. I put editor in a circle. Editor is what we in the biz would call a system program. In other words, it's not an end in itself. It's not an app that plays a game or anything like that. It's not a program that you're likely to sit down and fire up your computer and run the editor just for the heck of it. It's a helper program. That's what a system program is. A system program helps get these other jobs done that gets the real program or the real app ready to roll. So the editor is somehow connected with box 1. The compiler actually goes from box 1 to box 2, C-O-M-P-I-L-E-R. Again, all of this stuff is going to fill up the board in the next video. This is just all prep for this. So write this down so that you can refer to this when I'm just listing all these terms and talking about them in the next video. Now, a weird one, the mysterious one, connecting box 2. This is 2 right there. I'll make it a green 2. Sorry about that. Object code and library code somehow or another get linked together to the executable code. Oh, they do that through a system program called the linker. Surprise, surprise. L-I-N-K-E-R. All the things in green boxes, by the way, those are systems programs. Those are helper programs, auxiliary programs that help you construct your software. They help you help yourself. Okay, one more. To get from executable code into the core image, it has to enlist the services of a loader, L-O-A-D-E-R. Yikes, smeared green and black. Loader, L-O-A-D-E-R. Now then, circles are system programs. Boxes are stages, life cycle stages of your code. And I'm going to slip another term up here that I wasn't planning to talk about in this video, but I'm going to go ahead and break the seal on this. Often, rather than having a separate editor, separate compiler, separate linker, separate loader, all that kind of stuff, those can all be combined into one-stop shop, one package deal, almost like a shopping mall. One-stop shop, you get everything you want under one roof. That's called an IDE. IDE. An acronym, of course it is, Integrated, I-N-T-E-G-R-A-T-E-D, Integrated Development Environment. An IDE is an integrated development environment. It came along after these things had been invented, after there were already editors and linkers and loaders and compilers and all that stuff. And some bright computer scientist, or perhaps a team of them, said, you know what? We're using these programs together all the time. Let's just put them all together in one big happy package. And that way, you can enter your IDE, your integrated development environment, and do just about all of this, if not absolutely all of it. It's got an editor in it, and then a compiler, and then a linker and a loader, and you never have to leave the IDE to get it done. Isn't that cool? And that's what we'll be using for our programming. So even though all these activities are still done, it looks as if we're doing them inside one big program, the IDE. So why am I dragging you through all the separate green boxes? Here's the deal. These things still exist, even though they're integrated into that one development environment, a world of software development. Each one of these has its very own special error messages that it'll spit out. It'll tell you, no, I don't know how to do that. I don't know how to change the source code into object code, says the compiler. The linker says you're trying to use something in the library that's not over there, and I don't know what to do. That's a linker error. The loader, I don't know that we actually get, the only kind of error I can think of that we might get a loader is if we try to load a program that didn't exist. The loader is the one that copies our executable code. This is the version setting out in long-term storage on disk. Copies that into memory and tells the operating system, okay, we're good to go here. Another one to run. Sends us to the CPU. Tell it to do these things. Okay? This is an overview, and there's a glare there. I'm hiding the glare. Get this picture down, and we shall talk more about it later. But for now, I'll see you online.